Hello, this is Mr. Warden. This is a video key for the exit ticket for today. And I am going to go ahead and talk through a couple of problems here on this exit ticket for exit ticket 22.1. So you do want to remind yourself that if a line is perpendicular to a plane, then it's also perpendicular to any line that's on the plane and then passes through its foot. That's important. And you also want to remind yourself that if a line is perpendicular to two distinct lines that lie on that plane and pass through its foot, then it is also perpendicular to the plane. So what is the missing reason for the double statement in number 2? So the double statement here on our way to proving that triangle ADC is isosceles, the double statement is that AB, this is AB, is perpendicular to BD and then also to BC. So we're told that BC, D, and E all lie on plane N, which means that you can connect those dots and make lines that lie on that plane. AB is perpendicular to plane N, and that BE is the perpendicular bisector of CD. So you start to have information that will lead to Kappa-Kadaka, that will give us these two being congruent, and therefore these triangles will be congruent, and then ultimately these sides will be congruent. But we're just looking at how do we know that AB is perpendicular to BD and also to BC, and the reason it is perpendicular to both of those is that we know that the line is perpendicular, that AB is perpendicular to the plane, and therefore it is perpendicular to any lines that lie on the plane and that pass through its foot. So there we go. Because line AB is perpendicular to plane N, I think it was plane N, yes. Yes, plane N. And BD and BC lie on plane N and go through the foot of AB. And that's all you need for that. That would prove that. Okay, so we've got two proofs to do here. So actually, no, we don't. This one is going away. I'm not going to have this in the do now. So I apologize. That will not be there. Just one. So 4B, use what you already know about triangles and the information above to prove that BD, this is BD, bisects AC. So to do that, it would be really useful to be able to prove that this triangle and sort of the ends of this sort of lopsided bow tie structure, that those two triangles are congruent, because then you could prove that AE and CE are congruent by Kappa-Kadaka. So let's look at what information we have. We have AB is perp to plane N. We know, and that's a given. We know that CD is perpendicular to plane N, and that's also a given. And we know AC bisects BD, and that's also a given. Okay, now I'm going to scroll down a little bit so we have some room to work. Now, let's label the stuff we've got given now. We know that's a right angle. We know that's a right angle. We know that AC has bisected BD, so we can now say BE is congruent to DE. So here we go. BE is congruent to DE by definition of a bisector. Okay. Now we can also say that angle, so these two angles are vertical angles, so those angles are congruent. So angle AEB is congruent to angle CED because they are vertical angles. Okay, so let's label that information. Go with yellow for that. Flump and flump. Now I have enough information to say the triangles are congruent. So triangle ABE is congruent to triangle. Oops, that's not a congruent. Okay, oops, here we go. Is congruent to triangle CDE by angled side angle. And then we can say that AC is congruent to EC, or CE I will do, by definition, actually, no, I'm sorry, by Kappa-Kadika. And so therefore, BD bisects AC by definition of a bisector. And we're done. All right. Or C does not exist. But go ahead and let me know how you're doing with things. And I hope that was a helpful video explanation. I'll just leave that on the screen right now for a second. You can pause and check it out.